So, a very well good morning, good afternoon, and good evening to our esteemed chairs, authors, and other participants. On behalf of ISGF, I welcome you all for the presentation session of Select ISUW 2022 Technical Papers Part 2. Starting the session, I would like to extend a very warm welcome to the chairs for this presentation session today. So, before starting the presentations, I would like to inform that we will be having a 15 minutes time slot for the presentations, and in the last 5 minutes, we will be playing a timer so that we can stay as per our schedule. We will start with our first theme, which is Disruptive Innovations for Utilities, led by Mr. N. Murugesan. And a quick introduction about Sir. Mr. Murugesan is former Director General CPRI and advisor ISGF, and our chair for the technical papers theme Disruptive Innovations for Utilities. 40 years of experience in the areas of power systems, transmission and distribution system, communication protocol for power system, substation automation, distribution automation, smart grid, advanced metering infrastructure, smart meters, switchgear testing and certification as per national and international standard. So I would like to hand over the stage to Mr. Murugesan if sir would like to say a few words.
Friends, good morning, good afternoon, good evening. Friends, this last day of this particular program. And friends, in this particular one, there are lots of important papers have been packed, especially the power quality and grid interact to affordable housing, the grid management, and RPA powered self-functioning utility process ecosystem. And the need of the hour is that introduction of tower mounted substations. Very innovative the ideas and things like that. And there too all are from utilities. That's a very important thing. So we can take it from that without losing much time. I would like to invite the first paper by Mr. Lalit Vasan on peer-to-peer energy trading using blockchain technology. Over to Parul to introduce the speaker. Parul.
Yes, sir.
Yes.
So we will start with our first paper, which is peer-to-peer energy trading using blockchain by Mr. Lalit Vasan, AGM HOD for Power System Control and Battery Energy Storage System at Tata Power Delhi Distribution Limited. Without any further ado, I would request Lalit Vasan sir to kindly present the paper.
Yes.
Yes.
Hi, good afternoon, everyone. Just give me a sec.
Sir, there is some echo coming. Sir, we can see the presentation.
presentation.
Looks like two windows have been opened.
Yeah. Hi, good afternoon. Is my screen visible now?
Yes, sir.
Yes, sir.
Okay. Thank you. Thank you. So I would start my presentation. The presentation is basically related to peer-to-peer energy trading using blockchain technology. This one pilot which TPDDL has done in its own area. So before I go into the details of the project, I would like to explain a few things about my company. I work with Tata Power Daily Distribution Limited. This company is a joint venture of Tata Power and Delhi government, and this is a company which has shown transformational performance over a period of time. When this organization was formed in 2002, at that point in time, the losses were close to 53%. And now, after multiple technological interventions, skill enhancement, capability building, and various other initiatives, we are able to come close to 7%. So, this sort of transformation has happened in Delhi. We are operating in roughly one third part of Delhi. Being a power distribution company, uh, generally people perceive that they work in a traditional way. But now I can tell you, with more and more intervention of latest technologies, basically majority of the operations are being done with the help of various applications and PCs and laptops. So that sort of intervention has happened. We are basically 9001, 14001, and so on certified company. We are uh, basically every time trying to evolve. We always try to ensure that whatever new technology is coming in the market, we should be able to capitalize on that. We should be able to do its testing, see its impact, and depending upon its impact, we are able to roll it out. So in that direction also, P2P was one pilot which we have done. With this, I'll move to the main content. So in P2P, what exactly is being done and what are the advantages for various stakeholders? So when I talk about P2P, it is basically trading of energy between two peers. Take an example, there's a distribution transformer and that distribution transformer is say feeding to 100 odd customers. And out of those 100 odd customers, one customer is a pure customer and second customer has installed rooftop solar also on its roof. So during off-peak time, that consumer is generating surplus power which can be injected into the grid. And if that power is getting injected into the grid, at the end of a financial year, the settlement would be done and whatever money is expected to be paid to him as per regulatory guidelines would be adjusted at the end of the financial year. To avoid that and to manage peak load and peak shaming sort of things, option has been developed. As per that, the surplus generating customer, we generally call it prosumer, who is producing also, is able to sell the surplus power to any consumer who wants to use that power. So that trading would happen on real time basis. There are multiple methods of doing it. I would come to that. The complete transaction on P2P platform is being done with the help of blockchain technology. Blockchain technology is very, very transparent, reliable, and for every transaction, separate record is getting created at various levels. So chances of any malfunction or corruption are not there. Everybody is supposed to abide by the transaction which has happened. So few benefits of P2P are the local energy can be consumed below a particular equipment, say the transformer. It helps me to do the peak shaving. Let's say during the peak time when load is more, the uh, prosumer can sell the power to a consumer who wants to consume more. So peak shaving would be done. It would also help me in the capex optimization and network constraint management. Why? Because if the additional power requirement is getting met through the additional power generated under that discount, the distribution company is not supposed to incur extra capex on that. It also helps me to basically manage my RPO obligation. Many of you might be aware that for every distribution company, they are supposed to purchase a quantum of their power through sources. So, because this power is getting generated through solar rooftop, so this is catering to that segment. So my RPO obligation is also getting met. Next point is related to demand side management. In DSM, at the end of the day, if I feel that my load is more and some extra power, if can be injected by customers who are having battery along with the solar panel, can help me to basically sail through during the peak load time. So demand side management is also getting addressed. So moving back to the blockchain, what is the role of blockchain? It basically helps in settlement of transactions between distribution utility, prosumer or consumer, whosoever are involved into this. Because this whole transaction is happening digitally, so overall transaction cost would substantially come down. Human intervention is absolutely not there, because every transaction is getting recorded at multiple locations. Every block is getting imprints at every computer level or at every customer or consumer level. So there are no chances of pilferage, and information is being monitored, transferred in a very reliable and transparent manner. Customer, going ahead, I mean, customer is also having a flexibility to choose between the conventional, which is coal based power plant, vis-a-vis non-conventional. Take an example of this renewable energy source. So let's take an example of few MNCs who have got an obligation to purchase certain percentage of their energy consumption through renewable sources. So in that case, it properly fits into the bill. So what are the trading options? Broadly, there are three ways of doing it. First is fixed price trading, wherein a prosumer and consumer fix a price, let's say 5 rupees per unit. On that price only transaction would happen, and whatever transaction is happened is basically done, is communicated to all the stakeholders or both the stakeholders. And this whole transaction happens with the help of blockchain technology. There are multiple guarantee options also, which I would subsequently explain. Second is related to dynamic pricing trading. It is equivalent to the trade which you make in stock market or any commodity market, wherein the consumer or the first party can ask for X price and second party may ask for Y price. At whichever price, the strike price, the deal is done, that is the final price which is considered. That's why, because price can move in this case, so it is called dynamic pricing model. Basically, dynamic pricing with preferential trading. In this, I'll take an example of one customer. Let's say take an example of customer operating in Delhi. That customer is having an industrial unit and is operating in, say, Rohini area. His factory is in Rohini, and at the roof of that plant he has installed solar panel also. So during weekdays, whatever solar generation is happening, that is being consumed by the factory itself. But during the weekly off days, say the weekly off is on Saturday and Sunday, what he can do, he can use that excess power to offset the consumption being done at his home, which is same Pritampura. So he can do the preferential trading with the meter which has been installed at his home. So in a way, he would be able to save a lot of money on the consumption part. He would be required to pay only transactional charges. So what are the possible business models? First is, as I have already mentioned, between prosumer and consumers. Discoms are required to be taken into the loop. On that, wheeling charges and cross subsidy charges are required to be finalized by the state regulator. Billing would be settled through blockchain. Second option is between prosumer and discom. Let's say if there are no buyers. So in that case, the prosumer can sell that power to distribution company on mid-term and short-term basis, and based upon that a rate can be finalized and settlement can be done with the help of blockchain technology. Third is basically the emerging concept of EAS, which is energy as a service. In this, you must have read in multiple papers over a period of time that there are few players in the market who do the funding of rooftop solar. In that case, the customer is not supposed to spend any money. The financing party or the coordinator would come. He would ensure that solar panel is installed, power is purchased at a fixed rate, or power is injected to the grid at X rate, and whatever savings are accrued, based upon that, the funding model gets its money back. So these options are available as on date in the market. Multiple banks are offering, multiple renewable companies are offering this. So in that case, initial amount is covered plus the per kilowatt charges. Some trading charges are levied on per kilowatt hour which you are trading through this P2P platform. So ultimately, what is on table for everyone? For prosumer or producer, he would have additional revenue stream because panel would start generating revenue. Second, it would incentivize people to install more and more rooftop photovoltaic installations. So it would in a way push solar installation into at basically at the bottom of the pyramid level in this whole system. For customer, the cost would be less, promotion of renewable energy would be there. They would start participating in the DSM measures. For trader, there is also an option of for trader who can basically collate all the prosumers and can sell the power based upon that. You must have heard about few aggregators which are operating in Tamil Nadu, who are basically aggregating solar or wind power and are collectively bidding on behalf of those consumers. Next is for discom, there are few benefits. First is DSM is achieved, our capex deferment is there, our RP obligation is met, and at the end of the day, if our network is utilized for transferring power from one location to another, some wheeling charges or cost subsidy charges would be there, which would help us to offset few things. So in this project, roughly 110 odd prosumers and consumers have participated, and complete settlement, as I've already mentioned, was done through blockchain. In the subsequent table, the monthly transactions has been done. In real terms, if I mention roughly, if you see energy, let me just use the pointer, give me a second. If you see energy purchased through P2P during this pilot period was roughly 25% of total energy purchase, 7.56 plus 2.3, right? 2.3 is roughly 25% of that. So what I'm trying to say is whatever energy was generated with the help of rooftop solar, out of that 25% was traded through P2P and remaining 75% was injected into the grid, and that 75% would be get offset at the end of the financial year. So what are the recommendations, requests, needs to scale it? First is support is needed from Ministry of Power, MNRE, SERCs for framing the guidelines. As on date, because this whole stuff is at pilot state, guidelines are not available in Delhi, though UP has taken a lead and they have come out with some guidelines which may be used as a reference by states also. Second is tech neutrality is needed between states. Let's say there are two states. In one state, guidelines are different, and in another state, guidelines are different. And if a consumer is trying to purchase power from a prosumer who is operating in a different state, that process should be seamless. Third, clarity is needed on financial and legal settlement process. You would appreciate that because money is involved. Gradually, there would be some cases wherein financial or legal cases may come in. For that, a framework is needed which can help all the parties to basically take it up to the next level. Fourth is basically the requirement from all the stakeholders, from distribution companies, prosumers, government, regulators, that more and more adoption of blockchain is needed for taking these type of projects to the next level. Till now, blockchain was only being utilized in the financial sector. We have seen that it has a very important role in the power sector also. As we are able to see, it would reduce or eliminate a lot of manual interventions, a lot of anomalies. It would give a lot of flexibility to consumers to manage their load pattern as per their requirement. Thank you. Thank you.
Thank you very much, Lalit. Friends, then our next paper is on a very important topic, that is on least talked about topic on harmonics, which is now neglected by all the customer or utilities like that. So this paper will talk about this. Proactively, they have done this work, and also it will have effect on both the customer as well as utility. In addition to that, the study also mentioned that sometimes the higher harmonics will miss, get recorded. So there might be a possibility of energy losses too. So it's a very important study. So introduce a speaker, please. Parul?
Yes, sir. So the next presentation is for the paper power quality assessment at customer level. And the author for this paper is Ms. Ritu from Tata Power DDL. So Ms. Ritu, if you can unmute yourself and present your paper, ma'am.
Thank you, Parul ma'am. Let me share my presentation.
Also, I would like to request all the authors if we can keep the presentation for 10 minutes, and so that will be because we are slightly behind our schedule.
That is true.
Okay, so is it my presentation visible, ma'am?
Visible.
Okay. Good afternoon, all.
Go ahead.
My name is Ritu. I'm from Tata Power DDL, working in power quality team. And the topic for my presentation is power quality monitoring and assessment at customer level. Before starting, I would like to request you all to post your questions in the chat box. My colleague has all the questions there in the chat box. So, starting. During this presentation, I will take you through the following points. I'll start with the brief overview of Tata Power DDL. Then I'll be explaining about power quality and some of its important parameters. Post that, showcasing some key findings of our power quality monitoring and assessment study we did here in Tata Power DDL. And thereafter, there are some challenges which I'll share which we faced during our study. And finally, so starting with the introduction, Tata Power DDL is a joint venture between Delhi government and Tata Power Company. And these are some key performance parameters. Today, we stand at an AT&C loss of 6.6% and reliability indices SADI at 12.973 and SAFI 9.77. And I'm sorry, I'm having some glitch, I think. I'm not able to.
Ritu, you can reshare your presentation if you are facing any problem. You can stop sharing and then reshare. Maybe that
Okay,
will
ma'am.
help.
Let me reshare.
Ritu, we can't hear you. We can see the presentation.
Okay, now it's fine, ma'am.
Yes, yes.
Okay, so we were seeing at some performance parameters which we have achieved through the application of some world-class technologies like ADMS, Advanced Distribution Management System, Geographical Information System, Smart Meter, Smart Street Light Management System, Field Force Automation, and implication of energy efficiency systems, then rooftop solar and EV charging station. Now, as we have the penetration of energy efficient systems and solar and EV charging stations in our system, it's the time to monitor and assess the power quality distribution network as well in the consumer networks. So power quality is becoming an important concern nowadays for both utilities and customers, mainly due to three reasons. First is the application of modern process controls. Today we are having application of load which are more sensitive to the power quality variations. Like industries are having power electronic devices, adjustable speed drives, microprocessor based controls, which are sensitive to many type of disturbances. And these processes are more controlled, more interrelated, and more interconnected, which make them more vulnerable to these variations. If one system fails or malfunction, then we have very expensive downtime, which makes it very important to monitor power quality. Second is the distributed power generation. There is again some glitch, ma'am. I have to correct it. Sorry. Animating your अपना ले लेना I'll be sharing through another system.
Okay, okay. Please do that. Yeah. I have sent a request to you to unmute.
Okay, so sorry for the interruption. I was explaining about the power quality concerns, why it is an area of focus. Distributed power generation. Earlier, we were having power flow only in one direction from generator to load, but nowadays, as we are entering in the concept of smart grid, there are applications of distributed power generators on the power system. Like roof installation, solars, wind installations, which use applications such, and these devices create a lot of power quality problems. Third is the consumer awareness. Nowadays, consumers are becoming more and more aware about the power quality issues, and they are expecting a higher quality of power from their utilities, as they have installed more sensitive equipments within their facilities. Now, moving on to the next slide, power quality. Power quality is simply the like the quality of any other goods or services. Natural. Power quality is a characteristic of electricity supplied which make his product to work properly under given electric. Now, this is a huge concern for us, utilities and consumer both, because in earlier days, industries used to have standard induction motors, but now they are having more and more impact of this depends on three parameters. First is the deviation in voltage magnitude during the disturbance. Second is the duration of the disturbance. Harmonics. Harmonics are created by nonlinear loads like welding machines, arc furnaces, or power electronic devices, and any other electronic gadgets like hair dryer, computer, uh, and the impact of harmonics in the power system can be very.
Akshay, are you speaking something? Because we
If there is a presence of harmonics in that system, then an additional factor which is called distortion. Power factor in that picture is calculated by multiple power factor. Conventional power factor balance current, which is the different magnitude of current in all three phases. Then fifth parameter is flicker. Flicker is a sensing light and which can cause irritation to human eyes and brain of current in all three phases. Frequency deviations. It is a from standard supply frequency for India, which is 50 hertz. Now, I would like to explain about the process and the way we have carried out our study in Tata Power DDL, starting with the point of measurement, as it is a very crucial aspect in maintaining good power quality that power quality measurement is done at the suitable locations, because it is nearly impossible to mitigate these problems at individual load level. It will entail high investments in the system. So to tackle this problem, IEEE has recommended to measure power quality at PCC, which is called point of common coupling, PCC point. It's the interface point between operators network and consumer network. And it can be better understood by the help of this diagram. There is a utility supplying to 4 consumers. Consumer 1 is directly connected to the 11 kV bus. And 3 consumers, consumer 2, consumer 3, and consumer 4 are being served by a common transformer. Now, if you are interested in measuring power quality at any of these 3 consumers, consumer 2 or consumer 3, then the PCC point would be LT of this transformer. And now if you are interested in measuring power quality at consumer 1 facilities, then the PCC would be this 11 kV bus from where utility can supply to other consumers also. Now here's the case of industrial customer. Here, if an industrial customer is being supplied through a dedicated service transformer, and we are interested to take power, then the PCC point for us would be HT of this dedicated service transformer from where utility can supply to other customers also. And if you are interested in measuring power quality at commercial systems, which are being served through a service transformer, and from LT of that service transformer, other utility customers are also being supplied, then in that case, PCC would be LT of this transformer. Now, moving on, I'll explain the way we have carried out our study. We selected some different category industries to carry out our study and followed this study by DRC and followed DRC and IEEE standards in this study. This is IEEE 519/2014 standard on power quality. Here we can see that these are the limits mentioned for current harmonic distortion. Here one important point is that TDD which is the current harmonic limits vary from consumer to consumer. We cannot apply the same limits for all the consumers. Calculate it depending upon by calculating this ratio ISC by IL ratio, where ISC is the maximum short circuit current at the PCC point, and IL is the maximum demand load current, which is calculated by taking average of preceding 12 months maximum current, which we can get from the electricity bill of the consumer. And to carry out this study, we used portable power quality meter, PQ Box 150. And to analyze the recorded data, we used WinPeaky mobile software pertaining to this analyzer. Now, before entering into the next slide, I would like to explain a little bit about current harmonics. There are 2 parameters which can explain current harmonics. One is the TSDI, which is total harmonic TDD, which is total demand distortion. THDI is calculated as the ratio of total harmonic content, as the ratio of root mean square of total harmonic content.
Sorry to interrupt in between.
And the TDD is calculated by root mean square of harmonic content as a percentage of maximum demand.
Sorry to interrupt, but if you can wind up the presentation in 5 minutes.
Both will represent more or less the same figures. But now if there is a variation in the load from no load to full load, then THD values can be projected at very high values, because I1 will keep on changing from no load to full load. But in the TDD, we will have a more true picture of harmonic distortion in that particular consumer. So there is a discrepancy between THDI and TDD. So it is clearly mentioned in IEEE. Only inside a consumer premise, even if a consumer having high values of TSDI within a system. If TDD values are high, then there are chances that voltage we have harmonic analysis for industrial and commercial systems. First is the commercial hubs. Under this category, we covered around 6 to 7 consumer of crossing the limits. Then we have a station. We did this study for only one site and found that harmonic level there were out of limit. And then we covered core. Then also extended this distribution, and we selected some distribution transformers having a consumer band of 15 to 20%. So overall, only 29% of DTs are there which are having harmonic levels below 15%. Here are because it is the responsibility of operators only to supply all the consumers connected to that PCC point with a fairly constant voltage. Which we faced during
Ritu, can you hear me?
First is the complexity of the subject. As the power quality
Ritu, it's already more than 20 minutes. Hello, please stop. We need to close this.
Difficult to understand for both utilities
Stop.
and customers.
Ritu,
Regarding power quality
hello.
issues.
Just take.
Although consumers are aware, somewhat aware about the power quality issues, but according to most of the consumers, it is the responsibility of you to provide higher quality of power. They are not ready to accept this fact that who are being affected the most by these problems. Third, provisions regarding power quality, though
And stop it. Hello, I'm sorry, this is Raji Pillai. I had to intervene and stop. Everybody given 10 minutes and last two speakers taken more than 20 minutes. So I had to expel. So now setting a timer for 10 minutes for each of the speakers. Be able to close the session even before 7 o'clock. Thank you.
We will start with our next speaker, but before that, I would like to introduce Mr. Samer Chaudhury, who will be chairing the session further. I would like to give a brief introduction about years of experience. 11 years in the information and communication technology domain for the Indian state-owned Maharatna company Power Grid Corporation of India Limited, known as Power Grid. Mr. Sameer Smart Grid Forum and also had been a consultant smart grid for Power Grid for extending expertise and knowledge for the successful development and implementation of the smart grid pilot projects in state distribution companies. So with that, I would like to welcome Mr. Samer Chaudhury for taking the session forward. Sir, would you like to say a few words before we start with the presentations?
Yeah. Welcome, participants. It is a pleasure of the technical Indian Smart Utility International Week 2022. So as I am in the midst of a running session conducted by Professor Murugan, so I would like to continue with the next speaker. You have got a very interesting topic, that is RPA empowered self-functioning utility process ecosystem. Now, as you all know, am I visible?
Yes, sir. Yes, sir. We can see you, sir, and we can hear you well.
Okay. Now, this RPM is robotic process automation, is understood to be the latest breakthrough in the office automation system, and has got a very vital role in the utility process ecosystem. So today's presentation will be, there are joint speaker, Ambarish Amalraj Gaikwad and Madam Lakshmi Patel. One of them, I think, will be presenting now.
Sir, I would like to interrupt in between. We are done with the first two presentations. First one was peer-to-peer energy trading, which is augmented reality and other digital transformation applications with his presentation.
Okay. I've been taking charge in between. I somehow missed the sequence anyhow. This is the topic, augmented reality and other digital transformation and their applications in power system. Power transmission, this is the buzzword today with artificial intelligence and machine learning. The augmented reality has come to the center stage. So as you all know, Mr. Ravitek Electrical and Electronics from the CUPTU and PGDM IGNO. Mr. Robin has a work experience of with 9 years experience in startup or operation. So he has got a very unique presentation and topic to choose. So we'll all are very eager to listen to Mr. Ravin Giri, lead engineer, Tata Power Company. So over to Mr. Ravin Giri. Yeah, Mr. Giri, you can start your presentation. Mr. Ravin Giri, you can start your presentation. Parul, yeah, thank you. Yeah.
Yes, Mr. Robin, you're on mute. Please unmute yourself. I have sent you a request to unmute.
Can you?
Yeah, you're audible now. Yes.
Yeah. Please carry on.
Okay. Good afternoon, sir. Good afternoon, everyone. My topic is augmented reality and other digital transformations and their applications in power transmission. I am from Tata Power Company Limited, Mumbai. Just a minute. Vivek bhai. So, I am unable to switch to second slide. Can you hear me, ma'am?
can share from our side. if you
Robin,
wish.
we can hear you. Please go ahead.
Just a minute.
Robin, if you're not able to project, shall we do that from our side?
Just a minute, ma'am. Let me try last.
Yeah, yeah.
Okay. Can you see now?
Yes, yes, Robin. Please go ahead.
Okay. So area of power transmission is having many activities which needs digital transformation for higher productivity, reliability, availability, and just a minute, ma'am. Actually, this pop-up is disturbing. Increased performance and reduced operating cost. To explore digital transformation in power transmission, we did pilot project on a digital safety helmet, which is having camera and micro screen. In this paper, we will share the used cases of this device used for remote assistance through camera and micro screen with other features. In this paper, we will also discuss that how we can utilize augmented reality, virtual reality, Internet of Things, artificial intelligence, robotics, and other digital transformations in power transmission division to improve overall performance of the system. So first of all, I just want to tell about this RealWear helmet. We did a pilot project with the one of voice operated device, which is AI and IoT based. This device is mounted on a safety helmet as shown in this image. This device is having a micro screen targeting to one of the eye. And while we look into this screen, this is like looking tablet screen from one of the eye. It works like a smartphone or tablet for us. This device is also having a camera which can be controlled remotely. This device work on Android platform, and applications like Teams, Drive, etc. can be downloaded and used. So basically, this device helps us to free operation. Some of persons can argue that same functions can be done with the help of smartphone, but in a smartphone we have to carry that smartphone in our hand. But for this device, we are having hands-free operation. So considering the growth in the power network, it is necessary to speed up the maintenance and repair activities for uninterrupted power supply. To ensure this, we need to adopt new applications, which are combinations of AR, VR, IoT, robotics, and other technologies. Such applications can help in a great way for higher productivity, reliability, availability, increased performance, and reduced operating cost. Currently, many such applications like I share this are available and being used and helping to in improvement of power system performance. So just to give a brief idea about augmented reality and other digital technologies, augmented reality can be defined as a live, direct or indirect view of physical real-world environment whose elements are augmented or overlaid by computer-generated sensory input such as sound, video, graphics, or GPS data, like we see in some video games. Virtual reality is a computer-generated environment with scenes and objects that appear to be real, making the user feel they are immersed in their surroundings. This environment is perceived through a device known as virtual reality headset or helmet. Similarly, Internet of Things, artificial intelligence is having machine learning technologies and sophisticated algorithms that help machine and computers work smarter and more effectively. All we know about robotics, it is a design, construction, and use of machine robots to perform tasks done traditionally by human beings. Robots are widely used in such industries as automobile manufacture to perform simple repetitive tasks, and in industries where work must be performed in environment hazardous to humans. So now I'm going to share some use cases which we done on this RealWare device. One use case is that remote supervision of 110 and 220 kV cable termination work at towers. At one of our receiving station in Mumbai, there was a 20 feet height tower at which we have to connect the 110 kV cable. For that, scaffolding was erected and jointers were doing jointing work, termination work at that height. So for such a high voltage cables, engineers are debuted to monitor the measurements of terminations. So it is very risky and on safety point of view, it hazardous for persons to sit so many persons at such a height or moving up and down frequently. So we used this device. Engineer was sitting in the office and he was taking all the measurements from his laptop, and it was performed very successfully. And even engineer was able to perform some other jobs also. He was not dedicated to this activity only. Similarly, we see some trippings in overhead lines. For that, supervisors go on towers and check the conditions of insulators and terminations of cables. For that, engineer call them to send the photos, and it takes lots of time until engineer gets confident about the failure. So it was taking huge time, 3-4 hours. But with this device, as a supervisor was moving his head, all the visuals were available to the engineer, and he took the decision within 15 minutes. So this helped in a great way to us. Another used case is that at one of the power transformer at cable terminations inspection, a supervisor was going inside, but he was sending the photos, but engineer was not able to take the judgment that if failure is in the terminus or not, or engineer has to go inside the cable compartment at that height. But with this device, he used this device, and with that he see the clear images of clear live video of that cable terminations and got the judgment. So in similar way, assistance in cable testing, assistance in remote operations of switch gears, like operation engineers go into different substations, and when they do breaker or RMU operations, and they feel any difficulty in operating that, or sometimes it creates trouble to them, then he called to his colleague, and it makes very difficult to reach another colleague to that substation to help him to operate the switchgear. But with this device, as he's having hands-free operation, other colleague who is in his home or at his office can guide him that how to operate the switchgear. So see, these are some applications, and with this device, we can also fill some voice-operated forms. This device is Android based, so mobile applications which are voice operated can be installed and can be operated with this device. In the below image, you can see the screen. The video quality is very good. The person sitting in the office see the everything which is happening at site. Other than that, we also explored that some other areas are also there in transmission system where these AR, VR, IoT, AI can be explored, like GIS network can be seen in 3D by superimposing on physical roads. Live augmented reality video conference at site can be done between supervisor and officer. Cable jointing assistance can be provided through such applications. Cable testing assistance can be provided. Automatic cable drawing can be updated. Images can be captured in 3D through mobile applications and can be updated in AutoCAD automatically. If some external agency is excavating the roads and there are underground cables there, so the supervisor which is having this AR device or AR camera, he can see the routes superimposed on the physical roads, and he can guide to the JCB operators to avoid the damage to cables. Training to new trainee supervisors, contractors can be provided this VR device, and this is being done these days. Similarly, geofencing for safety, like field safety workers wear geofencing enabled sensor that continuously track workers' location and health. Accessing documents from site. Wearing digital device, site person can operate his PC and can access the documents. fast restoration of power supply. As we have seen that fast cable testing and fast repair will help in fast restoration of the power supply. Inventory management, augmented reality based glasses can help to find and arrange goods quickly. So few takeaways are there, because we have seen that AR, VR, IoT, AI, robotics, and these digital technologies can help in great way in various operation, repair, maintenance, inspection activities in power transmission business. These digital transformation will help for higher productivity, reliability, availability, increased performance, and reduced operating cost. Thank you very much, sir.
Thank you so much, Robin. Thank you so much.
Thank you, Mr. Robin, for your scintillating presentation. I think people have really understood the gravity of your area of specialty, augmented reality, and you have presented very nicely. So we will move on to next speaker for the grid interactive affordable housing, a grid management opportunity for distribution licenses in India. Very, thrilling topic. Mr. Mahesh Patlekar, founder of MP Systems Advisory Private Limited, and Mr. Craig Barton is a joint endeavor for their technical paper. I invite them for the presentation, and audience is very eager to listen to them. Thank you. Welcome, Mr. Mahesh Patlekar and Mr. Craig Barton.
Thank you, Mr. Chaudhury. So this presentation will be delivered by my colleague, Craig Burton, and in the interest of time, let him sort of continue with the entire presentation. Please do flag any questions that you may have in the chat box, and both of us will try to answer those. Thank you so much. Craig, please over to you.
Barton, Mr. Craig Barton, welcome.
Yeah, just give me a second. I'm just setting up my machine to share the screen.
Thank you.
All right. All right, just a second. I haven't shared with this before, so.
Mr. Craig, you will see a share button in the bottom of the platform.
Okay. Yeah, it's wanting me to quit and reopen, which is
Yes, sir. You have to open your presentation first.
Yep, I've done that.
Yeah, and then you go on share. Now you will see a tab for your presentation.
Yes, of course. All right. It's wanting me to quit and rejoin. Should I do that?
No. So we can do that from our side.
Yes,
I request the backend team to kindly upload the presentation for Mr. Craig Burton.
Thank you. All right, so thank you for this opportunity. And thank you to Mr. Chaudhury for chairing, and of course to Ms. Parul for organizing me and Mahesh to attend this event.
Thank you. Please carry on.
We'll wait for your slides to come up.
So it's uploading in a few moments. It will be up.
Sure, I might keep going. So this is a bit of a different presentation. It is tonight, and this afternoon, we've seen some great presentations about technologies and energy technologies. Our presentation is about an upcoming program of work to test energy technologies in real people's homes so that we can determine if they're going to be successful long term. So our presentation is specifically about testing grid interactive technologies in affordable housing. And we are often asked why we are looking specifically at affordable housing. And the answer is that I'm from GBPN, which is the Global Buildings Performance Network. And we are interested in decarbonising housing. And the affordable housing sector in India is a very large cohort to examine. And I have Dr. Patenka with me from MPEN Systems, but also the American NGO called Regulatory Assistance Project. And together we're funded to look at a great balance between grid innovation and housing innovation for a stable grid and for better home living. Can you take us to the introduction? Do you want to hit spacebar just once? So what is this about? So just hit the spacebar or down arrow. Thank you. So this is a scoping study and it's nearly finished. It's been running for about a year. And it is a study, largely a desktop study, but also a study to reach out and meet important people in India who have energy and housing innovations, and also to find hosts and to examine sites in India. And the thing that we're looking to do is living labs. So a living lab, as I said, is a kind of experiment, but it's an experiment with energy technologies to see if they'll actually be accepted into people's lives. The field is demand side management, which is familiar to many people here, but it's the study of things we can do on the consumer's side of the meter, as opposed to supply side management, where we might look at generators and cables and wires. The thing we really want to test in this series of living labs is grid interactivity. So grid interactivity allows the DISCOM to take action to control the load on the consumer's side to perhaps prevent blackouts, as an example. Can you hit the spacebar one more time, Parul, please? Or the down arrow? The two ways, the main way to do this is obviously through energy technologies, but at the sites where we're going to set up our living labs, we're also looking at building efficiency. So it really makes sense to try and reduce building energy use by also making the buildings themselves more energy efficient. And this way we're dealing with smaller loads to begin with. And the final thing of interest to us is occupant benefits. An empty building, an empty residential building, does not use any energy. So any energy interventions that we want to try out, they have to work in people's lives to be accepted long-term. And this is to make them attractive for policy change. So both RAP and GBPN are NGOs that provide technical assistance for policy change. Okay, next slide. There's three kinds of interventions that we'll be testing. One of them is interventions at design. So this is at building design before the building is actually begun. And here we will look at no-cost interventions to make affordable housing perform better, such as orientation, openings, shading, that kind of thing. Since most of the houses in India are already built, our second class of interventions are retrofits for residential. So what can we do to existing buildings to make them more efficient and grid interactive? And then, of course, most of our interventions are about new buildings and our behavior. So how can we introduce things that are low cost and that are going to be popular and successful? Next slide, please. So why do this? Why would we do these kind of interventions? Well, there's lots of reasons, but probably the most serious reasons for doing this are the projected amount of demand in residential. So you can see the two graphs at the top left were shown at a presentation by Anita Chaudhury given by USAID and Metri and EDS, and they show that the projection for 2040 is this huge evening peak in demand due to cooking and cooling. And At the bottom right here is a graph from 2018 by the International Energy Association, and it has 3 countries or sets of countries. And at the right, it shows that India is projected to experience the highest rate of variability due to demand and renewable supply. Of those 3 large countries, India will have very variable energy supply and demand. And so how will we address this? And we will address it with demand side management and grid interactivity. Next slide, please. What am I talking about when I talk about energy interventions and grid interactivity? What am I talking about? Well, here's one example of one of the things we would like to test. We will promote rooftop solar over and above the 20% of roof area for common power. We will put more solar onto our test buildings and then share that power down into the occupants' homes. At the same time, we would hope to introduce induction cooking. So the picture shown on the right here is a gentleman using an induction cooker. It's a kind of electric cooker. And I know some of you in the room with us today and people watching in the energy sector will know that something like this has a lot of assumptions behind it, because in order to benefit from a setup like this, we would want home occupants to change the time of day that they cook and change the device that they cook on. This is quite risky. And so this is why we're using a living lab to test this. If it's successful, if an intervention like this is successful after a couple of years of testing, then it can be used to stimulate policy ambition at the DISCOM, the ULB, or the SDA, so that more of this kind of transformation can occur. Next slide, please. All right, these 3 circles shown here are the main mechanism of the living lab. On the left, we run experiments. And these experiments involve community engagement, technological interventions, and at the same time, we perform these experiments with our government partners and our DISCOMs observing and helping us get these experiments right. At the top right, in sync with this, we have the DISCOM involved. So whatever the DISCOM is that is responsible for the network where we are sited, the DISCOM can observe what we're doing through AMI. We'll install meters and sensors. And the DISCOM can also try out software that we have for issuing commands to the building. Another example of what the DISCOM might do is issue a command to halt header tank filling. So if there's congestion on the grid in the area, the DISCOM might decide to halt water header tanks from filling for several minutes to reduce the chance of a blackout. And last but not least, again, you can see that at the bottom right, there's the policy life cycle. And so we're hoping to demonstrate things that allow the local government, first of all, to get involved, potentially to help us with regulatory sandboxes. So when we're testing things connected to the real grid, we may need regulatory sandbox. And then, of course, if what we do is convincing and successful, this provides a kind of naturalization for policy reform. Next button, please. Next slide, I'm sorry. This is how it might look. One of the interventions, the solar example I gave you, could be done through phones. So the occupants have phones and a message comes up saying, it's a sunny day. How about you start your cooking right now? Hit the spacebar, please. It's never been easier to do this. Thanks to the internet and thanks to mobile devices, this kind of monitoring and occupant messaging around energy use has actually never been easier. Spacebar, thanks. Again, why do solar panels? Because in the history of the galaxy, solar panels have never been this inexpensive. And finally, and I think most importantly, due to the risks of global heating and due to the mentioned risks to grid stability, there's never really been a better time to find a safe medium between energy use and energy supply. One more. Okay, and this is my summary. So I've introduced that we are going to do an intervention that will start later this year. We're finishing a fully funded scoping study. The living labs run till 2028, and everything that is going to be tested must be affordable. It has to have policy potential to be scaled up. We will give the participating DISCOMs control of building equipment, and we'll run behaviour change programs to help occupants adjust, with the goal of reliable, continuous grid power and lower energy cost of living homes that are cooler. These living labs will be hosted by Indian academic organisations, the Institute for Human Settlements, and also with the cooperation of the Mahila Housing Trust and my university, Monash University in Australia. And one more slide. Okay, so why don't you join us? The 3 places that we will be starting will be in Gujarat, Maharashtra, and Karnataka. We chose these places because of the policies and regulations they have there, and the relationships that we have. What we do, we hope, will be relevant for all of India. Please get in touch with myself or Mahesh, and Mahesh is listening on this call to take your questions in Q&A down at the bottom there. But that's my preso. Thank you.
That's great.
Thank you, Mr. Barton. To be precise and completing your presentation in time, and you are really deserving head of knowledge, innovation, global buildings. You are Monash University, Australia. Just like an academician, you have followed the strict rule of presentation. There are 3 rules. One is tell what you want to tell, then tell what you should have told, and then tell what you have told. You have exactly followed this principle. So I'm very thankful to Mr. Barton for your very interesting and very innovative presentation on a very new subject. Now any Q&A, please, people can ask Mr. Mahesh Patnakar. And then any query, please?
Sir, so participants can post their queries in the chat box, and I'm sure that Mr. Burton and Mr. Patankar will be here for some time. They can revert in chat box itself so that everyone can see what's the answer and what's the queries are. Will that be okay, sir?
Okay,
Yes, thank you, Parul.
Thank you.
That works.
Thank you, Mr. Chaudhury.
Mr. Barton and Mr. Patnakar, we are moving to the next presentation. You can answer people's query on chat. Next presentation is on RPA empowered self-functioning utility process ecosystem, and the presenter, paper presenter is Ambarish Amal Raj Gaikwad and Madam Lakshmi Patel. I hope one of them will present or both of them will be presenting. See, this robotic process automation is a buzzword today in workflow automation. So this is a very, this has become a center stage of office automation. People will be eager to listen to their presentation. So welcome Mr. Gaikwad and Madam Patel. So you can stop your slides, presentation, please.
Thank you, sir, for this opportunity.
Is it still visible?
Yes, it's visible.
So thank you very much for giving us an opportunity to present our topic on robotic process automation, that is RPA, empowering self-function utility process and ecosystem. I'm Ambarish Gaikwad, and my colleague Lakshmi will be accompanying me. She is also the co-author for this paper. Yeah. So we are from Tata Power. No need to introduce Tata Power, as most of you know Tata Power very well. So briefly, I would just get back that Tata Power is a business-driven organization, process-driven organization, wherein most of these processes are organized and in operational format. So we monitor each and every process, the digitalization index, how much the impact of that process is in terms of digitalized. Also, you may be knowing that the theme of Tata Group for this year is Being Digital. So we are just taking forward this theme and implementing this RPA, that is robotic process automation, in most of our commercial functions. So commercial means starting from application collection till revenue recovery. So most of these sub processes like meter reading, billing, revenue recovery, revenue assurance, enforcement. So we reviewed each and every process for this commercial aspects, and we checked over this digitalization part. So if at all we found out that the processes which were semi-automated or partially automated, using this digitalization index, we tried to take it up towards almost 90 to 95% automation level, what we have achieved here. Here we will be talking about few of these concepts which we used in our commercial aspects. Majorly, we will carry forward, we will showcase a few of these case studies and how we could achieve a high level of automation in that particular process. Yeah.
I will just briefly give an overview of robotic process automation. So what is robotic process automation? It is just a replication of all the human activities that are carried out day in and day out by humans. And these are some of the repetitive activities which do not need much knowledge, or maybe we can say it doesn't actually need any high level analysis per se, because it is the same mundane tasks which the human being has to follow and achieve to a final output, which definitely helps in decision making. So basically, when our business team have to complete a particular process, there are certain steps which are already automated and certain steps which are still done manually. And these manual steps, which actually consume a lot of time, can be automated through RPA, wherein RPA not only works on a particular application or a particular software, it works across the softwares. So be it our SAP system, which is our core business IT application, be it Microsoft Office or Outlook, be it some third-party tool. So RPA does an integration between all these applications and makes the life easier for our business teams. So what happens here is a bot is created in the system. A bot is nothing but a small program which follows a particular sequence of steps to achieve the final output. So if a human is carrying out 20 to 30 steps and he is spending almost 3 to 4 hours to complete that process, the bot does the same thing in the background and it reproduces the same output, and the business team just has to refer to the output and take certain important decisions. So this is the overall overview of RPA. We'll just go through a few of the use cases which we have already implemented in Tata Power Mumbai, and yes, yeah. So Amrish, you can take this.
Yeah. So in the screen you can see there are 4 of these processes which we tried using RPA. So first one is the bill quality check, second one is the meter data analysis, third one is the notification process, and then master data mismatch report. So in all of these processes, it was just a repetitive job what a particular person was supposed to do. Using this RPA, we have almost reduced that time substantially to hardly 10 or 15 minutes, which a traditional way of doing used to take almost an hour or 2. So mostly we can go for the next slide.
Yeah, so I would just
Yeah.
like to add here that we are also looking at horizontal deployment of all these use cases across Tata Power Pan India, and we have very interesting other use cases as well. We have just displayed 4 of the use cases, whereas we have already implemented almost 15 of them across other discoms of Tata Power.
So I will just explain you one of the process, that is build quality check in that. So you can have you can visualize how this RPA works, how this bot works. So just I'll give you a brief regarding what is BQC. So BQC is build quality check. So whenever we have readings entered in the system and we process the billing of, that is the utility bill for a customer, there are predefined quality checks presented in our SAP systems. Based on this quality check parameters, system gives us an exception report wherein we get a set of consumers which needs to be re-verified in terms of its bill, in terms of its bill amount, and there are around 10 to 15 quality check parameters. That is, let's say a bill amount, its meter reading, its outstanding dues, whatever is reflecting, or any demand penalty or a PF penalty has been reflected. So these are the quality check presets parameters which we have defined in our SAP system. So whenever a system gives an exception, a person on his own expertise used to analyze these cases, and somewhere to analyze around, so we can say daily there used to be around 1,000 cases which were exceptionally given by this report, and around 2 to 2.5, 2 and 2.5 hours used to take for a person to clear these cases. I mean, he used to scrutinize each and every of this case and clear it for further processing. By implementation of this bot, the cycle time reduction is from almost 2.5 hours to hardly 10 minutes. So you can see there are around 6 to 7 processes which used to be which are supposed to be done in this BQC process. Now all these processes by use of a bot are done in hardly 10 minutes. This is just a brief screen of whatever the program we are writing in our RPA developing tool. I'll just step down to the video so you can just view how.
So here we have just shown that a human would have gone through all the systems, the logins. He would have downloaded the data, collated into one single file, done a lot of validations, filtrations, and finally he would have got an output. So here you can see that the bot is automatically carrying out all those steps, and finally it is giving us the output where no human intervention is required.
Typically, here you are viewing a SAP screen wherein the bot itself has logged in to an ID in an SAP screen. The bot is giving the system the command what kind of data it needs to be extracted. Now each and every step of this SAP screen is shown here. So how this report is run in the bot. The bot itself exports this data into an Excel.
Just give us a minute. I think the presentation.
Yeah. So how, in terms of the data is extracted, how this data is automatically populated in our Excel. Even after extracting that data in Excel, the bot itself does a prerequisites analytics on this Excel sheet. From that, a summarized report is being done. And this summarized report itself is being sent to that particular associate who has to take an action over that summarized report. So right from extracting the data from a SAP tool till giving us a actionable data to a particular end, all these things are done in hardly 10 minutes. So this is a small video about it. Now we will just develop the benefits about it.
So to summarize this project, we have already listed down the business benefits that we have derived from this. I've already discussed, we are saving a lot of time that is put in by the teams manually. That is cut short. So the workforce productivity has improved since the team can now concentrate on more productive jobs. Reduction in errors because there is no human intervention and the bot is exactly going to replicate the steps as it is without any additional intervention. Then standardization of process, that means an individual would, if 3 individuals are working on the same process, they might differ in the way they are performing the tasks. So here there is no question of that variation. So that is why standardization of process has been achieved. Improved customer satisfaction because the accuracy that it gives while releasing of such exceptional bills is 100% and there is no error. And so we have reduced the customer complaints related to errors in the bills. And centralized analysis means the analysis which is done by the bot is shared to everybody on mail and it is already also stored on a common SharePoint folder where the person dependency is eliminated. And the last is improved digitalization index. So through this implementation, we have increased our existing digitalization index of commercial billing process from 90% to 96%. So that is also a great achievement. Thank you.
Thank you.
Thank you so much, Ms. Lakshmi and Mr. Ambarish for the presentation.
Very interesting presentation by Madam Lakshmi. So I think people have got a fair idea now about the benefits of the RPA in utilities. And next speaker, next topic is introduction to tower mounted substation, which is a core engineering aspect of our power systems. So speaker presentation by Mr. Swapnil Rai and Mr. Vikas Kaul. People are very eager to know about your interesting presentation, tower mounted substation. So your presentation, please. Thank you. Welcome. Mr. Swapnil Rai and Vikas Kaul.
Good afternoon.
Good afternoon. Good afternoon. Welcome.
Hope I'm audible and visible. So I'll just share my screen.
Yes, you are audible and visible. Please carry on.
Is the screen visible?
Yes, sir, the content, we can see the presentation.
So I'll just put it in the full screen mode. It's visible in full screen, right?
Yes, sir.
Yeah, so good afternoon, everyone. My name is Vikas Kaul. Along with me, Swapnil is also there. So the topic of our presentation is the tower mounted substation, for which we had written a paper. So we'll start with the existing scenario of the Mumbai. You can see there are 3 licensees which are operating in Mumbai in the distribution sector. One is Adani, BST, and Tata Power. So Adani and BST are having different license areas, and Tata Power is overlapping both of the licensees. And Mumbai is a vertical growing city. The cost of the price of land is very high. It ranges from 8,000 to 45,000 per square feet. And these are the problems which are there in the existing scenarios, that there is huge requirement of the substations which requires a much bigger footprint space. Then the developers are very reluctant to provide space because of the land prices. Plus, as I said, that there is a scarcity of the land which is available in Mumbai. So Mumbai is growing vertically, and the substation spaces are not available. So the challenge is space crunch, developer reluctance, and competition, since we are having a competition with BST and Adani. So if we will not be able to provide solution to a consumer, so our competition can, which is a very typical scenario available or limited to Mumbai city only. Now, the conventional substation, this is a very typical consumer substation, which requires a footprint space of around 40 square meter. It may be 8 by 5 or it may be 7 by 6, but the typical footprint required is around 40 square meter. So we did a brainstorming session internally to see what can be done to reduce this footprint size. So there are the solutions that are available in market, which we can use or one can adopt to have a smaller size substation. So one is a package substation, which are having all the components inside a package. Then pad mounted substations are there. Underground substations are coming up. It's very popular phenomena outside India. In India, it's also picking up pace. Then micro pad substations are also there, which are advanced version of pad mounted substations. And then we focused our interest on the tower mounted substation. So this is one more idea which can be used to have a lesser footprint space. So we designed this in-house with our own civil engineering team and our design team. So we were able to reduce the footprint area to around 16 square meter, which was earlier 40 square meter. So it is a G+1 tower kind of a structure with having a safe working environment with the safe barricading provided to us transformer. And civil strengthening design has also been done in-house by Tata Power. So these are just the snapshots of the drawings that we developed to have a very reduced footprint space. Now the differences that we can see between the tower mounted and the conventional substations is that the tower mounted substation augmentation is possible. The other solutions which I showed you, they are of fixed rating, and the augmentation is very difficult in package substations or micropad or underground. So in those designs, special equipments are required. In tower mounted, no special equipments is required. We can use existing equipments. In alternate designs, the OEM dependency is there. In tower mounted, there is no OEM dependency. Alternate designs are very costly, and this is in-house, so it's a very cost-effective solution. We have also made a comparison of the cost differences between the conventional substation or the alternate available substations and the tower mounted substation, where we can see that the cost is getting reduced by 50%. So we are having a saving of around 6.65 lakhs in the civil cost. Construction time is also reduced. It is up to 30 days only, as compared to conventional, which takes 45 days. And tower mounted substation also, we have made it in a way that it is portable. All joints are bolted. It can be disassembled, assembled anytime in a very short span of time. This is an actual photograph of one of the substation that we have recently commissioned in Mumbai. This is in South Mumbai, one of our BMC hospitals, Schneider Hospital. This substation, there was a footprint or in the space constraint, so we opted with this design. As you can see, all the equipments are sitting on the ground floor, and there is this tower kind of a structure and the transformer is mounted on the top. And this can still be customized. If more number of transformers can be put, it can be vertically grown towards the top. Now the innovation impact, we are having footprint reduction by 60%. A very good customer delight, as they are not giving up much of the land space. The design is in-house and very safe. There is no dependency on OEM, as none of the equipments are any special equipments that are used. We have used all the conventional equipments. This is the scalability and the key takeaways from this design or this innovation, that there is no restriction on the ratings. There is a ease of fitment and operation. It can be augmented anytime. This is highly scalable in urban cities like metro cities. Space crunch sites is provided with this solution, and it is designed with utmost safety. So these are the key takeaways on this substation on which we had written this paper. Thank you so much. Hope we have finished in time.
Thank you for your scintillating presentation. In
Thank you,
fact,
sir.
tower-mounted substation is a very big step to take on the challenge of Mumbai, scarcity of land, and this is a really technical innovation. And I'm sure the audience has been eagerly and very patiently listening to your interesting presentation. Anybody have any question, they can put in chat so that the speaker can reply. With this, we move on to the next presentation, Envisioning Smart Utilities through Field Force Automation by Nishant Singh, Manager Power System, Tata Power. So now this is a topic which is a very hot topic chosen by Mr. Nishant Singh. I personally thank you, because field force means the human team which has to take care in consonance with the technological progress. So your technological intervention is a must to help them out for the efficient operation. So I welcome Mr. Nishant Singh. Please, people are eager to listen to your presentation. You can start your presentation. Welcome, Mr. Nishant.
Thank you, sir.
Yeah, welcome, Mr.
So
Nishant.
please, thank you, sir. So please confirm whether my screen is visible or not.
It's visible.
It's
Nishant.
visible,
You can see.
Nishant.
Thank
You can
you.
see.
Thanks for the confirmation. Good afternoon, everybody. My name is Nishant Singh, and I'm working as a team lead of ADMS and FFA Operational Support Department in Tata Power DDL. And the topic of my presentation in envisioning smart utility through field force automation. Just a brief intro about my organization. Tata Power DDL is a joint venture between Government of Delhi and Tata Power. And as you can see, right after privatization, there has been a significant improvement in all parameters, whether it's operational or commercial related. And now moving to the technology evolution part. During initial time at the handover from DVB, all grid substations were old and non-communicable, and there was no dispatch center for centralized controlling of data. So the organization started with substation automation, laying optical fiber, and implementation of GIS. And then it went for SCADA for 66 and 33 kV level. Then in next phase, the company implemented distribution management system and outage management system. But the issue here was that any operation and SCADA or at DMS was not integrated with my SAP CRM, that is Consumer Relationship Manager. So there was this break of link, the flow of data. So it got solved after the implementation of ADMS. It is an integration of SCADA, DMS, and OMS, and based on a platform of GIS. So each and every in outage or an interruption data is now linked with the consumer database. So any break or operation triggers a packet of information in the form of SMS or the email, and it triggers it to the consumer for real-time updation of status. And now we have also implemented smart meter and field force automation, and has integrated with ADMS application. So the context behind this, the idea behind this installation of and implementation of this field force application was empowerment of field crew. We have data, we have lot of data in our control room, but this needs to get be utilized by my field executive working at site. We need to empower them through this data, and it helps to enhance the safety. And what we also did that we converted this FFA into a platform through integration with our various other technologies, which I will cover in later part of this presentation. So the significance of FFA for us is the main part is the auto scheduling and dispatch of complaint. The system takes care through the logic And the logic behind is the lineman closest to that particular fault will get the complaint. Plus there is also another thing involved in it, the previous skill set in handling that particular kind of complaint. Let's say lineman A is good at handling complaint of related to NCC, and lineman B is good at handling complaint related to street light. The average time taken by lineman XA is 15 minutes for street light. So the system will calculate and make a sum of the travel time plus the average time which he or she will take to resolve that particular kind of complaint, and based on that final sum, the campaign will get automatically scheduled. And to motivate our field executive, we have a band for like gold, silver, and bronze, where there is a competency mapping, and we have also integrated it through our section portal with FFA. And this helps in real-time dissemination of information to my field executive through FFA mobile app and to my consumer as well. And my consumer gets to know the real-time status, whether the lineman is en route and what is the status, whether the fault rectification has started or not, through this estimated time of restoration. So based on the fault type and the area of that fault, let's say it's a rural area or a urban area, because the time taken to resolve a complaint, let's say cable fault in rural area, is different from the average time taken to resolve similar kind of complaint in urban area. So the based on previous trend and restoration time, the system automatically calculates and projects that to my consumer through TV detail mobile app and the website. And it helps to faster restoration of outage, because the patrolling time is reduced, because FFA is linked with my ADMS, and ADMS is doing the uh, prediction of fault through the complaints which they are getting from call center. Let's say consumer A has made a complaint who is connected with my pole A, and another consumer B has made a complaint connected from that same pole. So instead of going to two different premises, the system will make prediction that this there is a fault at this particular pole, so lineman will go to that particular premise, will not go to that two different premise, and will directly go to that pole to rectify that fault. So it is reducing the patrolling time and the decision making time the system is doing for them. And as I was saying that FFA is integrated with my various IT OT application. The first one is ADMS. The next big thing about that integration is smart meter. We have a ping meter facility to know the real-time status of that smart meter and its connectivity with the next higher device, so as to make a decision. And it has also made my network connectivity, the consumer connectivity with my equipment, accurate. uh, and last but not the least, the authorization portal. So based on the competency which I was talking about, the lineman will get the complaint, and whether it's primary authorized or secondary authorized, this database is now linked with my FFA application. So only authorized employee can get to log in that particular application, and the work profile and the task will be allocated based on their competency level. Now coming to the features, the application has a dashboard view wherein one can see the real-time status and dependency of let's say MV call or plant shutdown or an interruption and the consumer affected. We have also done interlocking in report section, because we everybody knows the skill set and the qualification of our linemen working at site. So to reduce that time taking in filling that particular report, and to have that easiness and have standardization, we have created a single click button wherein one can fill the entire report through single click of a button, and all details will get auto populated. And we have created FFA as an N minus for my ADMS also. Let's say something happens to my control room. Let's say a terrorist attack happens or some other earthquake or disaster happens, and my control room activity gets disrupted. So we have a provision to shift our all call from SAP CRM by skipping ADMS to land directly in FFA. And this is the dashboard of our web application of our FFA, wherein all features are there which we can perform in our ADMS. This is the red DMP button, disaster management plan, wherein we can trigger and activate this feature. So this application, which is now a platform for our organization, for our field crew working at site, it has benefited all of our stakeholders. For consumer, there is a faster restoration of service. There is a transparency. They get to know the detail, their status with a click of a button. For employee, it is assisting them to make decision faster, because my prediction model of ADMS is linked with my FFA application. There is a route optimization feature which I was talking about, this auto scheduling and dispatching of outage, and it is helping us to utilize our resource deployed at field effectively. For organization, providing better services to consumer leads to improvement of our reliability parameter, and we are offering this FFA solution to other state utility also. And for safety, as I was telling earlier, integration with my Saksham authorization portal has uh, ensured the authorized employee work as per their competency level, and any unsafe situation at site gets reflected in my FFA application because it is linked with my Suraksha portal also. So let's say there is a pole tilted or any unsafe situation is that there, so that particular detail will also get reflected with a red mark. So the key takeaway for this project is the decentralization of control room information. Now we are utilizing more from the same data, because earlier it was restricted to control room personnel only, but now we have opened this information to our field executive as well. And this has improved the consumer delight by providing better services and in a transparent way. The effective resource utilization is happening because of auto scheduling and dispatch feature. And yes, there is a reliability improvement because of this application. Thank you.
Thank you, Nishant,
Thank you,
for the
Nishant, for the
presentation.
presentation. Very much, Nishant, for your informative and interesting presentation for field force automation. People who are interested for any Q&A, they can put their question on the chat box, and Mr. Nishant will be able to address it. Next speaker, Mr. Vinod Kumar Agarwal, importance of digital energy database and expert systems to promote excellence in the operations of the power utilities in different countries in South Asia. So Mr. V.K. Agarwal is a veteran in power sector, and he was in POSOCO executive director. So this expert systems energy database, these are very, very, buzzword in these days when energy and power grid is going to the internet model of information. So people will be very eager to listen to Mr. Agarwal's presentation. Welcome, Mr. Agarwal. You can start your presentation.
Okay. Thank you, Mr. Sameer.
Yeah. Welcome.
Let me share the presentation.
Yeah. Okay. Please.
Is it visible? Mr. Sameer, can you see the presentation?
In my computer, it is not, but Madam Parul, ma'am, can you confirm?
Yes, it's visible.
Okay, visible. Please carry on.
Thank you. So at the outset, I am okay. So this is the database thing I have. Sorry, I have to download another thing. Sorry for a moment. Yeah, so instead of the presentation, incidentally, the portal was linked. So is it visible, Mr. Chaudhury?
It's visible, sir.
Okay. So at the outset, I am thankful to India Smart Grid Forum for selecting our papers and giving us an opportunity to make a presentation on this subject. Co-authors for this paper are Mr. Pankaj Batra and Mr. Monish Makwana, my colleagues from SARI EI, and Mr. Dirgayu Kumar Shrestha and Mr. Tark Bahadur Thapa from NEA Nepal. SARI EI, that is South Asia Regional Initiative for Energy Integration. It is a program started under USAID initiative with IRADe as its implementing partner. And the main objectives under this program are to enhance energy cooperation and trade of energy amongst the members of South Asia country. And the focus area under this program are harmonization of policies and regulatory frameworks across the different countries in South Asia, enhanced transmission network amongst the different countries, development of regional power market, and development of clean energy in the region. So basically what has been seen for all these meeting all these objectives, the database plays a very, very important role, the information, availability of the information and all that. So we, under this particular program, we have made an efforts to develop a energy database and expert system utility. It has been developed. The earlier portal, what incidentally I had linked up. So that is the portal. It is already ready and we are doing some fine-tuning efforts in that. And the main objectives to develop the South Asian energy database and expert system are to act as a single source of information, to provide clean energy related data, to reduce data asymmetry and promoting data transparency, providing quick market-related information to the utilities involved in the cross-border electricity trade, helping different countries with data and information in the matters of energy trade, providing vital information towards facilitating renewables integration in the grid, and helping government organizations in the matters of planning. If we go slightly in the background and look at the need of the energy cooperation or enhancement of the cross-border electricity trade, we know that the electricity consumption in the different countries in the South Asia, if we take the average electricity consumption, it is very low as compared to the other parts of the globe. The per capita electricity consumption in South Asia, average value is of the order of around 705 units as compared to the global average of 3,130 units. The primary energy consumption in South Asia countries is 15 to 25 gigajoules per capita against the global average of 71.4 gigajoules. But if we look at the growth of energy demand in South Asia, the growth is very high. The annual GDP growth in South Asia countries is of the order of 6 to 8%. If we look this GDP growth in last few years, and this growth is on a rising pattern and almost double than the growth prevailing in the other regions across the globe. So there are 2 points. Currently, the electricity consumption value is very low, but there is a good potential. There is a very high potential for the growth. Then another important point is lot of diversity exists in the different countries in South Asia as far as the resources and demand is concerned. If we look at the RE potential capacity, the utilization factor is around 100 gigawatt against the 1800 gigawatt potential, that is around 5%. Similarly, hydro potential utilization is of the order of 18% only, 61 gigawatt against the potential of 350 gigawatt. What I intend to say is, since they are complementary, hydro and renewables, they can go and balance the grid and all that. These type of diversities, they can be used, and the cross-border electricity trade amongst the different countries in the region can be enhanced, which addresses the issue of the energy shortages. And naturally, for all these, in order to have the enhanced electricity trade and all that, in order to do the transactions, the enabled management information system and database, that can be very, very handy. The database, what has been developed is, it has the following main features: possesses time series data related to South Asian countries' energy sector, presents the results in a configurable and user-friendly formats. equipped with powerful reporting and analytics tool. This is another very important feature of this particular database. In addition to the database, it has a very, very important analytics tools have also been included, using which the operating personals or whoever has been using this particular database, they can find out certain specific solutions for the specific issues also. Then near real-time data updated in case of some of the critical parameters, presents complete picture about primary energy sources and energy balance. This is also a very important aspect which has been included in the database. When I say primary energy resource and energy balance, means coal, oil, gas, hydro. So all these primary sources of energy there, what has been their resources, what has been the production, what has been the import, export, what is the value of the total primary energy supply, what is the value of the final energy consumed. So for each of the South Asian countries, these parameters have been put in this database, and that too for a earlier duration also, maybe 10 years before also, on yearly basis, monthly basis, we can get these particular values. Then provides information about the regional electricity market and cross-border electricity trade, also equipped with the policy, legal and institutional related information. Now, as the different countries now, they are participating in the power exchange also, like Nepal and Bhutan already they have been participating in the Indian power exchange. Bangladesh also has the plans. So if this electricity market related, if data is available in a very, very user-friendly manner, then definitely this gives lot of weightage, lot of advantages, or lot of leverage to enhance the trade. This is the home page of the database. This is I have shown the link also. This is the link, and basically it can be accessed. It is working at the moment. And these are some of the data sets. So once we see, there are socio-economic and environmental parameters, which gives the area, land area, population, GDP, then carbon emission values. So all those socio-economic, all parameters are there. Power supply position, it includes, that is the energy demand met, what has been the peak demand, what have been the shortages, etc. It covers all the values of the cross-border electricity trade in terms of energy as well as in peak megawatt. Electricity generation capacity and fuel mix in each of the country. What has been the type of electricity generation, what has been the installed capacity, and what is the fuel mix, how much is thermal, how much is nuclear, how much is renewable. Then what type of energy is being generated from these type of sources on daily, monthly, yearly basis. Transmission sector overview, losses, energy resources, production, import, export, and total primary energy supply, as I had just touched upon earlier. And then energy balance, consumption and source-wise, sector-wise composition. How much load is being taken by the industry, how much by commercial, how much by the agriculture. So all these components one can find out. Electricity market prices and composition of short-term transaction of prices, electricity market volumes and trends of short-term transactions. So it basically gives all the trends also. If someone wants to compare what type of comparison is there between the power exchange prices or bilateral trade prices or deviation prices. So all those components in the different time frames, they are available in the database at a click of mouse. This is the architecture of the database. Basically, it is working on a active server mode with the load balancing features and with naturally as a backup server, etc., so that it is giving very, very reliable services. And on the right side, we are just seeing the different operating system and the domain which is being used. As far as the collection of data in this portal is concerned, it is generally on the technique of web crawling services, and all the data has been ported from the public domain. So whatever reports, whatever website data is available from the different countries in the public domain, it is capturing all data. Some of the data it is capturing, say, yearly, if values are there after every year, after month, and sometimes even 15-minute value also. For instance, in India, the scheduling is at the 15-minute interval. And In NPP side, the data is available at 15 minutes interval, or Power Exchange, the data is available at 1 hour interval, and all. So all those values also it is capturing from all the countries. And this is the method of capturing the data. And this is some of the typical pictures I am trying to show. Basically, if we look at the data, electricity consumption, for instance, the upper picture is giving for all the 8 countries. Similarly, the lower picture gives the population growth. Each country's data is shown in the different colors, and there are a number of trends. Those type of pictures can be obtained, and then we can, it has an auto scale conversion facility. For instance, India has a population of 1350 million and Bhutan has a population of 0.77 million. So if we want to look at the data for Bhutan, because if that would be, scale would not be visible, but since it's a auto scaling facility, the moment we disable higher value countries, naturally the scale would auto adjust, and very clearly we can go to the lowest value. This is the data, again, typical outcomes for the RE installed capacity. It is giving percentages terms, megawatt terms, fuel composition also in percentages, then fuel consumption by in terms of the primary KTOE. So all type of outcomes are there, number of outcomes are there. And the direct benefits from South Asia Energy Database to the stakeholders in South Asia, if we look at that. So it provides easy access to data and portability in energy sector, provides quick information about regional electricity market prices and trade, assists utilities in expediting the decisions towards cross-border electricity trade, helps countries in South Asia to enhance regional trade by using vital information, help government organizations in planning and decision making based on facts, and promote excellence in power system operation based on analytics and reports. Thank you very much. Thank you.
Mr. V.K. Agarwal sir, you have really summed up the real essence of the power exchange power system in your final presentation under the theme of disruptive innovation for utilities. I think the speakers have sufficiently made disruption in the thinking of the audience through their technological presentations. And in fact, the first disruption was when I took over in the mid of Murugan Sahab this session. But anyhow, I hope all the audience and also the presenters and the organizers have enjoyed all the presentation and they had learned a lot. But learning never ends. It is a continuous learning process for us. So if anybody has got any question, specific question to any speaker, they can send their contact them, or they can put in the chat box to be replied by the respective speakers. Thank you, Agarwal Sahab. So,
thank you, Mr.
Thank you,
Samir.
Agarwal Sahab. So we close this session with the theme Disruptive Innovation for Utilities, and we move on to the next theme of the today's last technical presentation sessions. The theme is Evolving Architecture of the 21st Century Grid with Two-Way Power Flows. Now, our first speaker will be Madam Yvonne Kaur, who will be presenting on, her subject will be an integrated approach on transmission planning studies for bulk renewable energy in evacuation in Indian context. Everybody of us is aware that how the renewable energy drive has picked up through the present planning of the government. So this is a very, very contextual, contemporary and interesting topic to be, the speaker will be Yvonne Kaur. I welcome Madam to start her presentation. She is from Starlight Power Transmission, Manager Substation Engineering. Welcome, Mr. Kaur, Mrs. Kaur. Thank you.
Thank you so much for this opportunity. Let me just share my screen. Just give me a minute. Okay, this is not opening.
Ivneet, shall we upload the PPT for you?
I'm trying to open it. My presentation is open in my window. Yeah, it's there. Okay. Can you see my screen?
Yeah.
Okay. Good afternoon, everyone. This is Ivneet Kaur from Starlight Power, and I'm here to talk about the paper on integrated approach on transmission planning studies for bulk RE evacuation in Indian context. So, to start this, as we all are aware of India's ambitious target to have renewable energy capacity of 175 gigawatt by 2022 and 450 gigawatt, which was recently increased to 500 gigawatt by 2030. Out of which 150 gigawatt is already installed as of November 2021. So for that, we know that in our country, resource-rich locations are concentrated in few pockets in western and southern regions. Hence, transmission becomes a critical element in Indian power system to enable transfer of renewable energy to major load center. So this paper talks about strategy to develop network models for transmission planning, including planning horizon, extent to which network to be modeled, and relevant sources of data for identification of planned generation, transmission lines, and load forecast. This paper also talks about the approach and performance criteria for transmission planning study to evacuate renewable energy power to intended load centers. A comparative analysis between HVAC and hybrid HVAC and HVDC transmission scheme is also being illustrated through this approach. So the data required for the development of base model for generation evacuation plannings are first existing power network data would be required to model upcoming generation for which evacuation system is to be planned. The network database should be modeled up to 220 kV or 132 kV for exceptional cases for ISTS level planning. This data is essential to identify additional injection capacity in existing substation. Next is load forecasting. This involves use of historical data to predict the future power requirements of a country, region, or state. Electric Power Survey report published by CEA, Central Electricity Authority, covers year-wise electricity demand projection of all states. Using this data, load growth is scaled for a concerned year. Next is generation expansion, which is driven to balance the load growth. The generation capacity addition are evaluated at frequent intervals for reliable power to all. A National Electricity Plan (NEP) is published by CEA once in every 5 years. Suggests about capacity addition, retirement year of thermal units. Using this information, thermal units which are going to be decommissioned, which are going to retire, will have to be decommissioned. And then SECI MNRE publishes details about upcoming RE schemes for which transmission line is to be planned. Next, transmission planning for RE power plant would entail identification of transmission technology based on distance from load center and determination of terminating and intermediate node in the network. NEP Volume 2 gives information about possibility of requirement of new transmission lines. After that, the collection of data and modeling. After the collection of data and modeling, the study assumptions considered for modeling new generation, load growth, and proposed transmission lines, along with relevant elements, are existing network that we have already talked about to develop the model. Upcoming 765, 400 kV and 220 kV transmission lines is to be modeled as per the data available. Upcoming generations are injected at concerned substation, and wherever information unavailable, injection is assumed to be injected at 400 and or 765 kV level. Next, for thermal power plants, retiring thermal generating units are decommissioned as per the NEP data available. For thermal generating units, which are already there in existing network database, are backed down to their minimum technical limits or shut down wherever required. For upcoming RE generations, these are modeled in lumps of megawatt or gigawatt range and injected at pooling points. For peak case scenario, shunt reactors are to be disconnected and shunt capacitor to be put into service wherever required. And in this scenario, we have also considered rooftop PV generation. This quantum is adjusted in the load in generation value. Next, for transmission line and transformer parameter, these are modeled as per the existing data or CA transmission line planning manual is considered for wherever the data is not available. For load is scaled up proportionately as per the existing load with respect to 19th EPS report published by CA. The power factor of the load is considered at 0.95. So with all this system assumptions and the data that you have collected, this study was then carried out on PSSA software. The analysis has been carried out as per the CA transmission planning criteria guidelines. The network database for this timeline is considered that whatever timeline you want to consider for the study, you have to first decide that. Then you have to take that network database based on the timeline you have decided. Then you have to put the study input you have to take first, that is generation in details. Here we have considered 20 gigawatt of injection, which is then injected into the pulling substation. Load growth as per the 90th EPS report that we have already talked about is considered, and the existing load is scaled up in this model. Then the study assumption that we have just talked about is used to model the elements. This planning study has been done in accordance with the various load scenarios and generation dispatch conditions, such as solar maximized peak case and solar minimized off-peak case. Post-modeling of elements power flow study was carried out to reach load generation balance for a future timeline. Along with the power flow analysis, short circuit analysis, and reactive power compensation study is also performed for different scenarios to validate size and requirement of compensation device. N-1 contingency study is also done for proposed transmission line as per CA transmission planning guidelines. After that, transmission scheme is proposed along with the required reactive power compensation. So next, to showcase the study that we have just talked to, transmission planning philosophy, a case study has been illustrated. Here we have considered Zone 1 as a resources state where the upcoming RE generation are planned, and then the surplus power, renewable power, is exported to Zone 2, Zone 3, and Zone 4. The quantum and the pulling substation that we have considered in Zone 1 is shown in this table. We have considered 20 gigawatt of generation that will come up in Zone 1. The division of the generation is as follows in this table, shown this way. And this upcoming RE generation is planned to evacuate through 400 kV or 765 kV voltage level. This upcoming 20 gigawatt generation may not necessarily match the power demand of Zone 1. That's why the surplus power is going to export to nearby zones. Hence, in this case, major load centers and adjacent load become the target for this upcoming generation capacity. The power is evacuated through 400 or 765 kV or HVDC links to various load center. This study incorporates two cases for power evacuation for RE parks, namely HVAC and hybrid transmission schemes. Next, we are going to discuss one by one both this transmission scheme. First, we are going to talk about HVAC transmission scheme. In this scheme, power evacuation of 20 gigawatt from Zone 1 is planned using high capacity, extra high voltage 765 kV AC lines with surge in SIL of approximately 2100 megawatt. And this power evacuation is planned using 3 power pulling substation via 2 intermediate switching stations. These switching stations have been used to feed power directly to load centers or to transfer power through existing underutilized infrastructure through LILO arrangements. In this scheme, power is evacuated through 765 and 400 kV power pulling stations to 2 765 switching stations. The generating stations are interconnected to accommodate any line outages. Then for hybrid transmission scheme, this scheme is studied to directly feed bulk power to a major load center. An HVDC link, as you can see here, is connected, or 5,000 megawatt is connected through between Zone 1 and Zone 3. This eliminates the requirement of 2 switching substations as well as 765 kV corridor of total line length of approximately 2,800 circuit kilometers. Using this HVDC link, This also reduces the ROW requirement as well as the HVAC lines. This scheme is proposed keeping in mind that most of the AC infrastructure associated with RE generation will remain underutilized during off-peak scenarios. HVDC scheme offer a lot of other advantages over HVAC scheme, such as it offers better controllability, stability of connected AC system. So from the analysis carried out for normal and continuously operating condition, the planned and existing transmission network on 765 kV and 400 kV is adequate to meet the demand for future growth. Both HVAC and hybrid scheme are adequate. Even though HVAC scheme is cost effective, hybrid scheme offer far more advantage, such as bulk power is injected into single node and the same is required to evacuate to distant load center through dedicated long distance HVDC link, eliminating the need of multiple switching stations that we require in HVAC transmission lines. It also reduces ROW requirement, which has time and cost impact on project. It also improves system security in terms of angles or voltage stability. The reactive power requirement would also be lesser with HVDC link. Reverse power flow capability of HVDC can be used to serve power requirement of zone 1 during unavailability of solar generation. Hence, with all these points, we need to consider these points while selecting transmission technology for evacuating of bulk integration of renewable energy along with increase in capex. Thank you so much for listening to me, and thank you for this opportunity to present my paper here. If you have any questions, you can please put your questions on the chat box and we'll be very happy to answer them.
Thank you, Ms. Scott, for your presentation. I hope people have enjoyed this buzzing topic of renewable energy evacuation in Indian context. So we move on with the next speaker, Mr. Monish Makhwana. On the top, his topic will be on another interesting topic, planning towards enhanced grid discipline and grid reliability in the power system operations in South Asian region. It's a very, very contemporary, important topic in terms of power system operation. The speaker, Monish Makhwana, is energy sector enthusiastic. That is a very interesting. So welcome, Mr. Makhwana. You can start your presentation now. Welcome.
Thank you very much. I will just put on my presentation. Hello.
Monish, I think it's taking a bit long to load your presentation.
Okay.
Can you reshare? Stop sharing and then reshare.
Yeah, sure.
Yeah.
Just do that. Okay, I think the presentation is visible now.
Yes, we can see the presentation.
Okay. Okay, so a very good morning to one and all. My name is Monish, and today I'm here to give a brief presentation on my technical paper on planning towards enhanced grid discipline and grid reliability in the power system operations in South Asian region. This paper has been co-authored by Mr. V.K. Agrawal and Mr. Rajiv Ratnapanda. I will take you to the first slide. Okay, so so the power system in the South Asian region has mainly 8 countries, where India is centrally located in the region. Currently, India has interconnections with the Bhutan, Bangladesh, and Nepal, and there are plans that interconnections with the Sri Lanka will be there in the upcoming years. So, uh, like every country in the South Asia has different attributes of power system. That varies, of course, in size and operation. And one prominent feature in the South Asian region is that different countries have different fuel mix. So they complement each other in terms of fulfilling the supply and demand gap of electricity. So, for instance, a nation can fulfill its energy requirements from hydro-rich countries. Similarly, hydro-rich countries, in the event of any shortfall, can take electricity from a coal-based economy or a gas-based economy. Now, if you can see that India has a very large power system, and the system operation runs at the level of state, regional, and at the national level. If I talk about the Bangladesh and Pakistan, these countries have mid-sized power system, and the rest countries like Nepal, Bhutan, Sri Lanka, Maldives, and Afghanistan, they have very small size of power system. The cumulative installed capacity in the South Asian region is 4,68,735 megawatt, and every country has a diversified fuel mix in their installed capacity. Now coming to the next slide, which is the cross-border electricity trade. So if you can look at the cross-border electricity trade, it has increased in financial year, and in financial year 21 it was 18.74 terawatt hour, which in financial year 15 it was just 9.38. So there is a multifold increase of cross-border electricity trade in the last 5 years, and it is expected that it will increase in the future. So we hope that cross-border electricity trade will continue to increase further. Now, cross-border electricity trade solves the reliability aspect. Cross-border electricity trade also solves economic aspect. So there are some key drivers which gives a major push to the cross-border electricity trade in South Asian region. One is the initiatives, the green initiatives, like One Sun, One World, One Grid. There is a matter of energy security, which still continues to be a concern in South Asian region. There is a matter of growing electricity demand. Then there is a penetration of renewable energy. Then there is opening up of few market products like day-ahead markets, like cross-border electricity trade in the region has been started on Indian Energy Exchange in India. And then there is a huge potential of 43.8 gigawatt of cross-border energy trade interconnection capacity by 2040. So these are some of the key driving factors which will push the cross-border electricity trade to increase in the near future. Now, the thing is, when cross-border electricity trade happens, when interconnection happens, so when many countries are interconnected, it puts a question on the power system operation, like what happens to electricity grid? What about grid discipline, and what about grid reliability? And how these issues are going to get addressed in the event of failure. So this paper is an attempt to answer those questions. So first, we should understand what is grid discipline. So basically, it is the adherence of operating rules and some procedures, criteria, and guidelines by a generator, transmission, and distribution companies with the sole objective to avoid any kind of grid failure that can arise due to withdrawal of more power. On the other hand, if I talk about the grid reliability, basically it refers to the ability of a system to survive or to endure the instability and disturbance or any kind of uncontrolled events or unanticipated loss of system components, and to ensure to provide seamless supply of electricity by taking into account scheduled or unscheduled outages. Now, there are some challenges in order to achieve the grid discipline and grid reliability in the South Asian region. First challenge is there are 8 countries, so they have different sets of regulations and technical standards. So there is lack of harmonization across countries which are involved in cross-border electricity trade. There is lack of adequate commercial mechanisms like incentive and penalty mechanisms for deviating from norms. Third challenge which we have identified is that there are different regulatory institutions all across the 8 countries and regulatory statute. They are at the very maturity levels. So the objective of this paper is to suggest some of those regulatory measures or interventions that will be needed to ensure grid discipline and grid reliability in South Asian region from the perspective of regional integration. So these are some of the indicators that defines that explains the grid discipline and grid reliability. One is voltage variation, frequency variation, frequency response, planning a reserve margin, grid disturbance tripping, angular stability, and system adequacy. Now, these are some of the regulatory gaps which were identified in the South Asian region. So it is basically an extensive, exhaustive list of regulatory gaps. I will pick up few of them. So while examination of the South Asian region countries, it was found that system operation aspect such as operating procedure outlining, operational planning, system security, demand and outage management, these things are absent in all countries except India. And there is absence of imbalance settlement mechanism also. Talking about one of the important aspect, which is scheduling and dispatch, there is an absence of a detailed framework of cross-border electricity trade all across the nations, specifically in Bangladesh, Bhutan, and Nepal. Similarly, there is absence of standardized manual on system planning. There are inadequate measures in system construction and safety. If I talk about information and communication technology aspect, standards for cybersecurity standards for critical information infrastructure, these things are absent in all countries. While India have some kind of framework in information and communication technology, but India has partial gap. So there is a scope for further advancement. If I talk about on monitoring and compliance, there are inadequate performance monitoring indicators. There is a lack of provision to publicize information on public domain related to power system on of power system. So all these gaps are majorly due to four factors. First, it can be a loose sector framework. Second, it can be a loose formation of institutions. Third, there is incomplete or not defined regulations, rules, or certain kind of codes. And there is incomplete implementation and compliance of measures. So at the same time, let me also state that India is the only country that has adequate measures. But when it comes to interconnection, when it comes to integrating the countries, where all neighboring countries participate as a buyer or as a seller, the regulatory gaps should be filled. So as I was talking about the identified regulatory measures which will be required to achieve the grid discipline and grid reliability, they are system planning, system construction and safety, grid connection, system protection, commissioning and testing, system operation, scheduling and dispatch, information and communication technology, monitoring and compliance. So based on these identified gaps and after reviewing and analyzing the existing relevant electricity regulations and mechanisms with respect to grid discipline and reliability and with respect to cross-border electricity trade, we have come up with these suggested regulatory measures and interventions. And we also hope that, we strongly hope that there should be a regional regulator or an independent body in South Asian region, which will be needed, that will work on implementing these interventions. Now, we have picked up a few case studies. So this case study is the governing framework which the European Union has published for the grid discipline and grid reliability. So European Union region has a very wide number of transmission system operator. So the European Union established a guideline and it has stipulated the governing framework that defines a very crisp, clear and explicit roles for the transmission system operator. So they have specific guidelines for outage coordination. They have specific requirements for scheduling between all the transmission system operator control areas, and they have framework for load frequency control and reserves. So the key takeaway from this case study is that the governing regulation in the region should ensure a coordinated operation of that regional network. And those regulations should also ensure the uniform rules for the participants for non-discriminatory access to transmission network for cross-border exchanges in electricity. The second case study speaks about the North America Electricity Reliability Corporation. So North America Electricity Reliability Corporation has dedicated a specific center, a dedicated center, which is Electricity Information Sharing and Analysis Center, which serves as the primary security communication channel and enhance industry's ability to respond to certain cyber and physical threats. So the key takeaway from these case studies is that there should be a dedicated center in the South Asian region which should indicate the need for seamless flow of information among all the stakeholders and all the market participants in order to achieve the ultimate objective of grid discipline and grid reliability. Now, there are a few recommendations which we hope to make. So first is that a country-wise roadmap covering suggested regulatory interventions should be there, like for short-term period, then for medium-term period, and for long-term period should be required. And all those interventions which I have highlighted in the earlier slides, so a region which has a different operating framework, which has a different system security measures and different key institutions, that requires a neutral entity that should and that must oversee a coordination of operating frameworks which should govern system operation activities and control practices. Thank you.
Thank you for your scintillating presentation on a very contemporary issue of grid discipline and grid reliability, which is very crucial and is of vital importance for a healthy and sustainable operation of a grid connected power system. Now we move on to the next theme of the presentation, that is regulations for the evolving smart energy systems. In the new theme, our speaker will be respected Mr. Florian Kine. Aggregated demand side flexibility, a suitable and cost-effective solution for stabilizing the power grid. Welcome, Mr. Florian Kine, Chief Technology Officer, Panitech Power Private Limited. So, welcome for your presentation starting. Okay, you can share your slides.
So, you're able to see the screen?
Yeah.
Okay. Thank you very much. Thanks, Samer, for the introduction, and thanks for this possibility and opportunity to present our technical paper about aggregated demand-side flexibility as suitable and cost-effective solution for stabilizing the power grid. My name is Florian Kind.
Welcome. Welcome. We are eagerly waiting for your presentation. Welcome.
Thank you very much. Thanks for having me. I'm taking care of technology at Panitech Power, and we'll go with you through this interesting topic. So what's the challenge? Experts agree that balancing supply and demand is one of the most challenging problems in the transition to a climate neutral energy system. And this is mainly because of two factors. On the supply side, we have this shift from centralized traditional non-renewable plants towards solar PV, wind, hydro, and energy storage system. On the demand side, we see electrification, often also called convergence or sector coupling, which means the transition away from the fossil fuel-based heating, cooling, and mobility towards electricity used for these purposes. And this all leads to an increasing volatility of the energy system. It leads to less predictability and more congestion in the grid. And as an example, I like to show this electricity production graph and with the spot market prices of Germany. I've taken here Germany as an example because the net installed electricity capacity is about 220 gigawatts, out of which already 60% is renewable and 40% is conventional. And what we see in green is the feed in of renewable sources with the very high fluctuations throughout the week in the renewable electricity production. We see in gray the frequent adjustments which are required to the utilization of the baseload power plants in order to meet and balance the grid. And what we also see therefore are these steep and rapid price changes of the electricity price throughout the days and the weeks, which even exceeds €100 per megawatt hour within a few time slots, for example, here, based on the very high fluctuations of the renewable electricity production and the cheap sources of those. And this immediately explains the increasing volatility which is there in the grid and the requirement, the need for the flexibility in order to stabilize the grid. So currently we see about 4 main balancing services in India, which is the scheduling and dispatch mechanism, through which load dispatch centers plan the injection schedule. We have the deviation settlement mechanism, which is a regulatory mechanism used for grid stability by imposing penalties and incentives for over and under draw and over and under injection from the schedule. Auxiliary services reserved used for frequency regulation stabilization. And the real-time markets, which established only 2 years ago, where GenCos and DISCOMs can participate in the energy exchange on a real-time basis. As the most recent change in this ecosystem, we see the CERC Auxiliary Service Regulation, which has a focus aspect on aggregated demand-side assets to provide flexibility. So, for this ongoing, extremely important energy transition, the shift to renewable sources is the initial step. So replacing equipment with sustainable solutions and building up new solar PV and wind power plants is one of the most important factors, but this requires a high amount of investments and time. At the same time, digitization is ongoing, and in order to speed up the transition, we have to benefit from this ongoing digitization, which allows to monitor, control, and optimize power flows for specific purposes. So it allows for using flexibility, which can be provided on the demand side. Demand side assets are already there, they are already built, and if we use them, it's not only ecological, it's also economical, because it unlocks an untapped potential from these existing assets and processes. So what are these demand-side assets which can provide flexibility? I'd like to introduce this graph on the right-hand side, which showcases the flexibility in time and the flexibility in power of various assets. And for example, we have HVAC units here in the lower corner, HVAC units and heat pumps, which allow for a flexibility in time of a few minutes, maybe half an hour, and provide a few kilowatts, maybe 100 kilowatts in flexible power. We have EV charging, which allow for a slightly longer time duration for flexibility, but also a few kilowatts. We have this huge area of battery energy storage systems, which typically can be activated within seconds and allow for flexibility over maybe a day or so, and allow from several 10 kilowatts to several megawatts in power. And then there is this huge group of already existing commercial and industrial equipment, namely furnaces, ovens, boilers, reheaters, but also industrial drives and mills, which typically are in the megawatt range and allow for a lot of flexibility to provide it to the energy system. And typically the onboarding effort is not proportional to the provided flexibility. So providing flexibility by an HVAC unit or 10 megawatts by an oven requires the same amount of control equipment, interfaces, etc. So therefore, typically flexibility based on these assets, it's one of the cheapest sources. How does this work? We have the energy market and value propositions here on the right-hand side depicted. We have, for example, the load dispatch centers, which require balancing services and auxiliary services. We have DISCOMs, which can use flexibility for congestion management or deviation settlement optimization. And we have energy markets. On the left-hand side, we have the flexible assets, which we just discussed, assets, processes, and appliances. And in the middle, we see the aggregator. The new role of the aggregator is to aggregate these assets, to combine, to organize the assets, to pre-qualify them for the specific energy market and value proposition, and to do the bidding and dispatching of these. So therefore, the aggregator provides the real-time flexibility to the market and therefore gets a consolidated market revenue, which is shared as an incentive with the owner of the flexible asset. Aggregated demand-side flexibility is already existing as an established tool in many countries. We see many market segments and growth domains. For example, as already mentioned, greenhouses, pulp and paper industry, wastewater treatment, and buildings are already onboarded in several countries for providing flexibility to the market. And we see these growth opportunities, as mentioned, also the renewable integration, smart charging functionalities, energy storage management, and widely used district heating and cooling. Interestingly, aggregated demands and flexibility can provide substantial benefits to all stakeholders. So not only the resource owners, the commercial and industrial businesses, which benefit by reduced electricity costs by earning additional revenue from providing flexibility and get insight into the consumption and the use of their asset, and maybe also get the ability to reduce greenhouse gas emissions and optimize the CO2 footprint. We also see benefits for the discoms and the energy companies, the energy service providers, which have an additional revenue cut from balancing services, which might benefit from reduced peak power purchase costs, the arbitrage from that, and the deviation settlement penalties. There's also an accelerated shift to fossil fuels, from fossil fuels to renewables, and there is an increased depth in the value creation and the customer binding when it comes to the customer experience and the additional services. On the TSO, the grid operator and the load dispatch center side, we see this reduced grid operation cost, as mentioned. We see the very fast reaction when it comes to frequency reserves and auxiliary services. We see a more sustainable grid, and we see cost-effective solution to manage grid constraints and grid congestions. So overall factors and benefits of demand flexibility. As a closing remark, we have the participation of small assets to large ones, which allow for additional source of revenue for domestic, industrial, and commercial consumers with flexible loads. We see a maximization in renewable energy and energy storage integration into the energy mix. It helps to decarbonize the system. It might allow for deferring network capacity additions required to meet the peak load demand. And it also might help discoms in congestion management, reduce deviation penalties, and improve reliability indices like SAIFI and SAIDI index by providing better quality of supply and better quality of service. And for sure, the decrease of the use of fossil plants for grid balancing and the reduced CO2 emission per consumed unit of energy is one of the biggest advantage of using flexibility for stabilizing the grid. Demand-side flexibility is one of the cheapest sources when it comes to auxiliary service for grid stabilization. Thanks. Thank you. Thanks also to my co-authors, Pankaj Patra, Federica Tomasini, and Payal Gupta.
Thank you. Thank you, Florian Kind, for your precise and absolutely scintillating presentation. You are a Master of Science degree in Electrical Engineering from Zurich. So you showed your perfect skill of presentation as well as depth of knowledge in this presentation. Anybody have any question, they can put in chat box and contact Mr. Florian Kind. Thank you, Florian.
Thanks.
you.
Thanks very much. I'm happy to take questions also via email and chat box. Thank you very much.
Thank you. Thank you very much for your presentation. Thank you. So now next, we move on to the next speaker, and the theme of the presentation will be regulatory intervention on distribution reform. The speaker will be Mr. Ravindranath Sen. Welcome, sir, to this ISGF Smart Utility Week seminar for the technical sessions. So yours will be on the regulatory intervention distribution reform, Mr. Ravindranath Sen, former chairman of WBSEB, WBRE, Electricity Regulatory Commission, WBRC. And I hope Mr. Sen, Mr. Ravindranath Sen, you are ready with the presentation. Welcome.
Good evening, everybody. Thank you, Mr. Chaudhury and the ISGF for giving me the opportunity, especially Parul for inviting me in this session, because already I made a presentation on this yesterday in the regulatory platform. My presentation is basically on evolving regulation for the evolving green grid for this 21st century. So the way you have seen that the renewable energy penetration is happening, there will be lots amount of regulations are required, and number of regulations are already been introduced in the system. You are starting from your power. I mean, all those things, everything has been introduced. Now, I will basically be focusing on the microgrid. I will not go into the whole lot of the, power system, because with this thing, what is happening, we find that the people are very concerned about the quality of the power. People are very concerned about the reliability of the power. People are also very concerned about the availability of the power during the 24/7. Now, we are proposing to have a microgrid in Indian scenario, when the rural and also semi-urban, we have a combination of biogas. Biogas is mainly produced from all those animal waste and the agricultural waste and other things, whatever is available in the vicinity of those locality. And those biogas will be used for the purpose of the generating of the power in the evening peak, and maybe sometime to support wherever there is a requirement. The day generation will be basically made on the solar. So it will be combination of the solar and biogas, and sometimes the new technology which are coming into different mini or micro hydro, mini or micro wind turbine, mini or micro, all those, new things are coming. They will be also supporting this. Now, the whole purpose of this microgrid is to see that the reliability of the power is made available, and it will be spread across the different periphery of the main grid. And also, whenever somebody is looking for a quality power free from those, the harmonics and all those things, then they'll be also switching over to microgrids, like the way Microsoft and other people are switching over. Now, the purpose, what I'm trying to say is that the solar generation will be basically supporting the day generation, evening peak from the biogas, and night power. The whole change of the system, what I am suggesting is basically that this will be not be a standalone, or this will not be a separate from the main grid. It can be separate, it can be standalone, but it can also be connected to the main grid. Because main grid has a surplus power during the night from, say, your 12 or maybe one morning to, say, 5:30 or 6 in the morning. So this power, which is generally based on the technical minimum of the nuclear and thermal, which will be made available, then the generation from the wind power, generation from some other overflowing of the hydro and all those things, those power which are generally very cheap, instead of burning their gases, they can source this power from this sector, which will be very cheap and which also have connectivity with the grid. Now, for all these things, we'll be needing a substantial amount of smart technology to, switching over from one to other by sensing the frequency by sensing the time, by sensing the demand, all those things are to be sensed, and based on they have to switch. Then also based on the price, because we are also looking for a real-time pricing for all the power which will be basically supplied to the microgrids, so that he can, inject the power in the main grid whenever he has surplus, but he will not be getting in the concept of net metering. He will be getting the cost in the sense of the real-time cost of the power. Suppose during daytime the power is surplus, so automatically cost of power will be cheaper. So he will be injecting in a cheaper price. Similarly, when in the midnight he will be drawing, that of the power cost will be cheaper. So he'll be getting the power at a cheaper price. But if he wants to draw the power in the evening peak or something which is the peak hours, so he will have to pay much higher cost. So the whole thing will be highly dynamic, and to ensure this dynamic system is operating, we'll have to go for a host of regulation, host of technological intervention, host of so many things. So yesterday we have deliberated on this subject, and something is coming out that we will have to go for a roundtable with the selected people and come out with a discussion paper so that it can really address all the issues which are going to come for this purpose. Now, what we see that we'll have to also ensure to see that as far as the consumers are concerned, the standard of performance. I don't know how many of you are aware of the regulation called standard SOP regulation, which is basically available across all the regulators in the country, and the consumer are supposed to know all those things, which gives them the right to get the connectivity, get the power, get the in case of any stoppage of power, he is supposed to be compensated. So we want to see those things, sir. So automatically the requirement of the grid, your microgrid will be further enhanced, and microgrid will have to also ensure those things are maintained. Now we are also in the last phase of the Electricity Amendment Bill 2021, which is already in the Parliament, and we are hopeful that once after the election, again the budget session start, this will be introduced. I know that once this bill is introduced, there will be a number of things which are there, and out of one, the major thing which is going to be de-licensing of the distribution. Now, once the de-licensing of distribution comes, automatically the microgrid also will be in a better position, and they don't have to really look for the regulations which are exactly, make them to work in the environment of the main licensee. So we are looking into, and these also have given a lot of other initiatives which will help the microgrid to really come up, and the consumer also will be in a better position to get the supply from his preferred source of supplier. We are also looking for the implementation of ERP as a another intervention, which will ensure everything is fully transparent, and this will also ensure that the adoption of green power, because there is a resistance from all those licensees, which will they basically say that the green power is very costly, it is very disruptive, all those things. But the moment we switch over to transparency into ERP, those things will be visible, and will be, as a consumer, as a regulator, will be positioned to take that correct decision. Then Government of India has come out with one more, order, which I think most of you have seen. They are injecting out 3.3 lakh crores of money for upgrading the whole power distribution sector, which they call it reform-based resulting performance, which will be introduced for the next 5 years. And they are looking to that the whole infrastructure, the competency of the people, what you call the total, everything they have addressed. So I would use specific timeline, and this will certainly make those things very strong, and the implementation of the microgrid also will be much more beneficial with this subject. Government of India also issued one letter to all those distribution, all the state government, for handing over the 33 kV asset to the state transmission utility from the distribution. This was issued in the 1st of September 2021, and with a target date of handing over as early as possible. So if these are handed over, then we are seeing that all those 33 kV assets, these microgrids, they can directly get connected with the stress transmission utility by bypassing the distribution utility. Automatically, their things will be much more easy and they'll be in a better position to perform. And this will be certainly helping the distribution licensee also to save their, subsidy cost for the agriculture and the what you call domestic consumers. Then, as far as peer trading is concerned, whenever there is a no main grid available, the microgrid can get connected with it themselves. Already, this has been tried, and your project has already been done in the Delhi, and it has come out successfully with the support of Indian Smart Grid, and we are sure this will be also a thing which will help us to look for the peer-to-peer transfer of the microgrid as we have power from the green energy. Now, while some of we see the microgrid at the periphery of the distribution network will certainly help all of us. It will help the distribution licensee because as the generation will be in the place where it is being consumed, so AT&C losses will be substantially reduced. The agriculture and domestic supply will be substantial. Get the benefit from the microgrids and their cost subsidy and the losses because of the distance transmission, all those things will certainly be addressed. The regulator should ensure the implementation of a Ministry of Power later dated 1st September that is transforming with handing over the 33 kV and above transmission system to the STU from the distribution licensee, from which the microgrid will get directly connected and get the smooth power flow. Consumers through cooperative in promoting microgrid may be encouraged through suitable regulation and soft funding by multilateral agency. Then basically by switching over to microgrid, all of us, those who are living in urban areas will really find it is very difficult to, sometimes we feel very congested and we try to look out for the green environment, running to the hills, to the sea, to the forest, and so we'll be in a better position to operate from the position, from the villages, from the remote areas, and we'll be in a better position to really get all the facilities there and also use all the waste, whatever available in and around us, and to be connected to the nature and save our planet through distribution generation at the consumption point. And this will also help us to, minimize our dependency on fossil fuel. All of you are seeing that dependency on fossil fuel really brings a lot of, economical and financial shocks to the countries like India, where we are 80% dependent for import of the oil and a large amount of coal. So if we are, as we are coming out from the fossil fuel dependency, we will be generating our energy from the natural resources available in and around us, will be in a much better position to really live a beautiful and beneficial life. With this, I thank you. Is there any question? I will be happy to answer those questions. Thank you very much.
Thank you. Thank you, Mr. Sen, for your very informative and educative presentation. I'm sure all were really glued to their screens to hear you, such an experienced speaker addressing a large audience. Thank you, sir, for coming over here and sharing your presentation. Anybody having any question? So they can put on chat box or contact Mr. Sen. So here comes the closing of the final theme of presentation in the technical session, regulations for the evolving smart energy systems. So with this, I thank all the participants, organizers, speakers for the scintillating and very vibrating event. And then I hope the knowledge sharing has been very, very effective and practically useful to all the participants, as well as the speakers also have also could share their knowledge in this big international platform. Thank you, sir. Thank you. Thank you all.
Thank you so much, Sameer sir, for chairing today's session. And I would like to thank all the participants, all the authors also for joining us for the presentation session. Thank you, Sain sir. Thank you, Mr. Vinod Agarwal. Thank you, Mr. Robin and Monish for joining us.